Good morning, class. Happy Monday. Welcome to another week of online learning. Today we are continuing to learn about triangles in math, but we're going to look kind of starting at this anchor chart today, okay? Because we're learning about the properties of isosceles and equilateral triangles. These are two maybe new words to you. So they're listed right here. And we're going to be learning about them today. So what you're going to need is your spiral book and your textbook, okay? Because what we're going to do is start by looking at page 61 in our textbook. So take a minute and get that out and pause me if you need to. But let's have a look right here, okay? So we're going to have this open. And then I also need you to start your note. So don't forget to write today's date, Monday, May 10th, and then please write this as your title. And again, I know it's a bit of a longer title, so please pause the video if you need to so you can see, and I'll get out of the way. But it's properties of isosceles and equilateral triangles. So this is Isosceles, and then equilateral, Equilateral, triangles, okay? Because I'm going to tell you, and they're on here too, what the properties are, okay? So, an equilateral triangle is a triangle that has three equal sides. Okay, so please write this down in your notebook. An equilateral triangle has three equal sides. So all the sides are the same length. And it's interesting, the word actually tells us that, right? Equi means equal, and then lateral actually means the sides. So it literally is saying equal sides in the word. Okay, so that can help you remember that equilateral means that the triangle has three equal sides. So looking in our textbook, let's see here. Which of our triangles are equilateral triangles? Have a look. Looks like A and C are equilateral triangles. And we can see that they're equilateral triangles because all of the sides are the same length. Okay, this one has 8 centimeters and this one has 10 inches. Okay. So those are our two equilateral triangle examples. Okay, and next, a triangle with just two equal sides is called an isosceles triangle. So Isosceles is a triangle. Has two equal sides. Okay? Because interestingly enough, this word also is telling us what it means, because iso also means equal, and then celes means legs. So it's talking about how it has two equal legs, which funny to think that a triangle has legs, but it just means that there's two of them, right? Like we have two legs. The two legs of the triangle are equal. So that's how you can remember that an isosceles triangle has two equal sides. Okay? So let's look at our textbook and have a look. Which triangles are isosceles? So we can see that B and D are, because B has two 10-inch sides and D has two 8-centimeter sides. But here's the kicker. A and C also count as isosceles triangles because they have two equal sides. They just happen to have more than two equal sides, okay? But the rule still fits. So all four of these triangles can count as isosceles triangles, but more often we're going to see isosceles with just two equal sides and then a different length side, okay? So please make sure that you have this note written down. Pause the video if you need to here so you can see it. Or you can copy it off of this little set. And just so you know, we're not going to be learning about scaling triangles very much this year. You're going to learn more about that next year, but I put it on here because it completes the set of rules about categorizing triangles according to sides, okay? Like those are the three options, but this year we're just going to focus on these two, okay? So it's just a little bonus triangle there. You can copy your note from that spot too if you'd like, okay? And once you're done that, I would like you to get out the set that I've sent home for you. So I've given you these. And please take good care of them because we need to bring them back to DCA when we're all together. But let's grab these now and make ourselves some triangles, okay? So first, I'm gonna make an equilateral triangle using my green lengths. And they've given us the lengths here. It's 8.66 centimeters, but all of these are the same length. So when we put them together, they just snap into place. We have here an equilateral triangle, and it's an equilateral triangle because all three sides are the same length, okay? So I want you to take a minute and measure the angles of these triangles, and let's see what the angles are. This triangle, oh, and here I'll face it to you, has an angle. This corner is 60 degrees. And this corner is also 60 degrees. And this corner is also 60 degrees. So take a minute and measure that. Let's make a different one. Here's my next equilateral triangle, and I made it with the yellow length. I'm going to look at the angles. Oh, and we have 60 degrees here. And 60 degrees here. And 60 degrees here. So that brings us to a rule that we're going to keep talking about on later dates, that the equilateral triangle has 3 60-degree angles, and that's the rule. It's always going to have that. Okay, but let's look at some isosceles triangles. So I'm going to make them using 2 purples and an orange. And I want you to be making these too with me, because this is a lot of fun. Oh. If I could just get them to clip together. There we go. So with an isosceles triangle, I'm going to measure the angles. And this one is looking like it's set at 70 degrees. Okay, so let's look at this corner. This corner also comes in at 70 degrees. Okay, so we have the 2 bottom angles are both 70 degrees. So let's tip it on its side and look at the top angle. And the top angle is coming in at 40 degrees. Okay, so the top angle is not the same as the 2 bottom angles valued. Okay, let's look at a different one. And this time I'm still using purple and orange, but I'm going to use 2 orange and 1 purple to make an isosceles triangle that's a bit of a different shape. Okay, so this is still an isosceles triangle, even though it's kind of short, because we still have 2 lengths that are the same. Okay, so let's measure our angles for this one. So this one, I'm going to line it up. Looks like it's coming in at, I would say, about 45 degrees. Yep, 45 degrees here. And then the other one, the other bottom angle, also comes in at 45 degrees. And our top angle I'm just going to tip my triangle over to get the top angle. And would you look at that? We've made a right triangle. This top angle is 90 degrees. Isn't that cool? So a right triangle can be an isosceles triangle, okay? Because we have 45 plus 45, which equals 90, and then we have our 90, which equals 180. So isn't that cool? Okay, so we can make isosceles and equilateral triangles with these fun things. And I want you to spend time today making isosceles and equilateral triangles using these pieces that I've given you and measuring the angles to see what they are, okay? So you can do that a little bit more after this video is finished. But for now, I want you to flip to page 62, okay? So on page 62, you can see that we have an isosceles triangle, and you're welcome to grab a piece of paper to make your own isosceles triangle like I have here. The key thing that you need to do, of course, is to measure two sides and make sure that they are the same measurement. The third side doesn't have to be the same measurement because we know that isosceles triangles have two sides with the same measurement. And you'll see in the textbook, they've put lines, little ticks, little dashes that are perpendicular or opposite to the side line, okay? And these little dashes indicate that the two sides are the same length, okay? So just so you know, going forward, that's what those little lines are telling us, okay? So looking at this exercise, we have our isosceles triangle, and I've measured these two sides to be 15 centimeters, so they're the same, okay? And we can fold it in half. Like this, just like the textbook has done. I've folded my triangle in half, and you'll see that the angles are equal. Okay, so the angles that are opposite, or kind of, you know, a part of the equal sides, are equal. So when we have an equilateral triangle, then we have our two equal sides, the angles that are opposite. So, you know, this is one of the equal sides, and this is the angle opposite, and this is one of the equal sides, and this is the angle opposite. So kind of crisscrossy, but they're at the feet of the two equal sides. These two angles are equal, okay? Which is very cool. We're going to be looking into this a little bit more coming up, okay? And so you can see in number 2, the same thing. It tells us this time that angles x and z, or sorry, yxz and yzx, these two angles, are equal angles. And that's another way that we can tell that this triangle is an isosceles triangle. Okay? So if the two angles of a triangle are equal, then the triangle is an isosceles triangle. Okay? So we're actually going to write this last note on the board. Okay? And we'll do a dash because it's part of the isosceles triangle. If two angles of a triangle are the same, it is an isosceles triangle. Okay, and that rule is on our last anchor chart for triangles, right here. Okay, if two angles facing the equal sides are equal, then it's an isosceles triangle. Okay, and that is it for math today. So we don't have any extra textbook or workbook work, but what I want you to do is play around with these a little bit more, okay? So you can switch them all together and change them up. You can use 2 greens and a purple, or If you want, you can look at all three different and see that all the angles will be different because it's not isosceles. But take a look at different triangles that are isosceles and measure the angles and see that it's true, okay? So spend a couple minutes just playing around with these guys, and that is your only task for math today, okay?